Hey guys, so now that we're done with our terrestrial biomes, we're going to go ahead and jump into our aquatic biomes. So at the end of this lesson, you should be able to identify the major freshwater biomes and then identify the major marine biomes as well. And the marine biomes are going to be our saltwater biomes. So freshwater biomes have a low salinity, which means they've got low amounts of salt in their water. And these include streams and rivers, lakes and ponds, freshwater wetlands. So a stream and river, we've got flowing fresh water that may originate from underground springs or as runoff from rain or melting snow. Streams are typically narrow and carry relatively small amounts of water, where rivers are usually wider and carry larger amounts of water. So in terms of flow and the way that the water actually moves, streams and rivers are actually very similar. It's just we distinguish the two based on their size. So streams will be smaller and rivers will be larger. Lakes and ponds contain standing water, so these are freshwater biomes that do not move, so there's no moving water. They're stagnant. And then at least some of it is too deep to support emergent vegetation. And emergent vegetation are like plants that grow in the pond but then emerge out of it to capture sunlight. So partially submerged, the roots are located in the pond or the lake itself, but then the actual like foliage itself comes up out of the water. Lakes are larger than ponds, but there's not really a clear point at which a pond is considered large enough to be called a lake. When we think about ponds, a lot of times we think of them as like what people have in their backyards. You can kind of like easily see across it. And then lakes are very large, will support larger boats. Think about Lake Norman, if you guys have ever been to Lake Norman. And then there are some zones we need to be aware of when it comes to lakes and ponds. So the littoral zone is the shallow zone of soil and water in lakes and ponds where most of the algae and the emergent plants grow. So in the littoral zone, that's where you'll find the plant roots that will come up out of the water. The limnetic zone is just the zone of open water in lakes and ponds. Phytoplankton is floating algae. The profundal zone is a region of water where sunlight does not reach. So this is located below the limnetic zone in very deep lakes. So profundal zones you find mostly in deep lakes where it's deep enough that the sunlight cannot penetrate to. And then a benthic zone, and it's cut off a little bit in this presentation, but the benthic zone is just the muddy bottom of a lake, a pond, or an ocean. So we do have benthic zones in both freshwater and saltwater aquatic biomes. And here's just a depiction of these. So here we've got our emergent rooted plants. So again, the roots are in the actual pond, but the plants grow up. So think about like, you see these a lot in marshes, and they're oftentimes located towards the shore of a lake or a pond. Here is our littoral zone, which is the open ocean. The limnetic zone, which is just below. Sunlight can penetrate into the limnetic zone. And then the profundal zone we find in very deep lakes, and it's where sunlight cannot reach. And then if we look at our benthic zone, this is just the muddy part of the lake or pond. Lakes are classified by their level of primary productivity. So basically how much vegetation, how much photosynthesis is going on in the lake. An oligotrophic lake has a low level of productivity, so these lakes would be clear, not have much vegetation in them. A mesotrophic lake describes a lake with a moderate level of productivity, and then a eutrophic lake describes one with a high level of productivity. And later on we'll talk about why this isn't necessarily a good thing. But for now, we just need to know that a eutrophic lake will have a lot of vegetation and it will tend to be a little bit murkier. There's a little bit more kind of going on in terms of photosynthesis in a eutrophic lake. A freshwater wetland is an aquatic biome that's submerged or saturated by water for at least part of the year, but shallow enough to support emergent vegetation. These are among the most productive biomes on Earth. So when we say productive biome, we mean they're doing a lot of photosynthesis. There's a lot of vegetation producing energy through photosynthesis. And then those are your freshwater. So now let's talk about your marine biomes. So there are 5: salt marshes, mangrove swamps, intertidal zones, coral reefs, and then open ocean. A salt marsh is a marsh containing non-woody emergent vegetation found along the coast in temperate climates. We have a lot of salt marshes along the coast in North Carolina. Again, just like a freshwater marsh, these are one of the most productive biomes in the world. Salt marshes, they kind of have a distinct smell. They have like really muddy, fertile soil, and they have emergent vegetation that looks kind of like really tall grasses, but they're not woody. A mangrove swamp is a swamp that occurs along tropical and subtropical coasts and contains salt-tolerant trees with roots submerged in the water. Mango trees are salt-tolerant and they help protect the coastlines from erosion and storm damage. So mangrove swamps are actually very important to help kind of protect coastal areas from damage, especially from things like hurricanes. Intertidal zones are the narrow band of coastline between the levels of high tide and low tide. Waves that crash onto the shore in this biome can make it a challenge for organisms to hold on and not get washed away. Coral reefs are the most diverse marine biome on Earth. They're found in warm, shallow waters beyond the shoreline. They're also very endangered right now, so coral reefs are very susceptible to climate change. The oceans are acidifying, and when coral reefs are damaged, we do lose a lot of our biodiversity. So even though that they're found in water, they're some of the most diverse marine biomes. And they're relatively poor in nutrients and food, but a lot of organisms gather around coral reefs, and so they just become very diverse. Coral bleaching is something that's happening, and that's a phenomenon in which algae inside the corals die, causing the corals to turn white, and they basically just die, because corals are living organisms, but coral bleaching is basically the death of a coral. Open ocean, deep ocean water located away from the shoreline where sunlight can no longer reach the ocean bottom. And just like our lakes, we do have different zones we need to be aware of. The photic zone is the upper layer of the ocean water that receives enough sunlight for photosynthesis. The aphotic zone is the deeper layer that lacks sufficient sunlight for photosynthesis. So A means without, photo means light, so this just means without light. And then chemosynthesis is a process used by some bacteria in the ocean to generate energy with methane and hydrogen sulfide. So there are methane vents on the bottom of the ocean floor. And certain bacteria have evolved to use chemosynthesis rather than photosynthesis. So they're using chemicals to create food instead of sunlight. And then here is again just a depiction of these different zones to help us figure them out. So the intertidal zone is here between the high and the low tide. We typically have this shelf, so when you guys go to the ocean and you go out, you don't immediately drop down into the open ocean. Typically, we don't go past this kind of drop-off point. But we've got our photic zone, so photo again means light, so we've got sunlight penetrating, and then we've got our aphotic zone where sunlight does not come down. And here are these little vents where the methane comes up, where the bacteria are able to create food based on the methane that they can get from these vents. And then just like in our lakes and ponds, we also have this benthic zone, which is just the muddy part and the bottom of the ocean. And that's it for your aquatic biomes. I know that went really quick. You guys do have an assignment for today, which is a speed dating assignment. You have each been assigned either a terrestrial or an aquatic biome to kind of put together some information. You will not be able to answer everything just from these PowerPoints. You might have to use Google to help you, or your textbook, because the textbook has a little bit more information on these. But if you guys have any questions on that, make sure you let me know. And that's it. The good thing about the aquatic biomes is that you don't have to worry about climate diagrams with those. So the aquatic biomes are going to be just easier to identify all around. But if you guys have any questions, make sure you let me know. And that's going to be the conclusion of your lesson 2.